So welcome everyone. I'm hoping everyone is having a good day. So today we are going to talk about how we can implement an event sourcing strategy on Azure, and of course by using Azure Custom B. So quick introduction. I'm El Troteboer. I come from the Netherlands. I live in Rotterdam, where I work at a company called Motion 10. We basically focus on everything Microsoft and Azure. I'm also an Azure MVP, so I love working with the community. And of course, you can always contact me on my Twitter handle. And today I'm here with Olena, but at least virtually.
Yeah. Hi, everyone. My name is Olena Borzenko, and I work in a company called Rust Express. I live in Germany, and originally I'm from Ukraine. Of course, if you have any questions or comments, feel free to contact me on Twitter as well.
So let's have a look at what is event sourcing. So event sourcing basically means instead of having a database with the object in there, creating an object and updating it, instead we are going to use events to basically make our events represent a complete object for all the events. So let me explain this a bit better. So what we are going to do, we are going to create an order. So this is an event order created. Some information in there about the order, what's the order, maybe who was delivered to, stuff like that. Then the next event might be, okay, we added 2 t-shirts. Then another event might come in, like, okay, we added 4 hats. And another event might come in, shipping info added. And now when our client comes to this order, he will get these 4 events, and then he can combine these to get the end state of the order, where he has an order with 2 shirts, 4 hats, and some shipping info. So this is basically event sourcing, where we have these events, and together they create an end state of an object. So why should we use event sourcing? So event sourcing is used instead of databases. So on databases, we use CRUD, where we create, read, update, delete. So instead, this is nice if you have like a low number of inputs. But when you have like thousands, hundreds of thousands, or millions of producers, and they're all trying to update these different objects, we might run into some locking issues. Because the same object might be being produced at different places. And when they try to write, they are locking issues. And this will slow down our systems, and we might run into some issues. So the problem is that the CRUD is not really easy scalable because of these updates. Another thing is very difficult. So concurrency means that we might have like one producer that's reading a state, updating it, but in the meantime, another producer might come in and also do the same thing. So at that point, the state might be running out of sync. And finally, with a database, we don't have out-of-the-box history. Of course, we can add this ourselves. We can create tables around this, but there's no out-of-the-box for this. So why should we use event sourcing for this then? Event sourcing doesn't update objects. It just does inserts. So this means that it's perfect for those write-heavy workloads, right? We all are writing this data all the time. Because inserts are much more efficient. So if you just do inserts and don't do updates, we can make this much more efficient by just calculating the end state of these events. And of course, we have a built-in autolog now as well, because we just have all the events, and we can see, okay, what events came in, and we can just rebuild this and replay this.
Edit, I do have a question. You mentioned before that we have a problem with scaling. Can you tell us how it's going to work with event sourcing?
Yes, definitely. So with event sourcing, of course, like I said, we are just going to all these inserts. So as long as you have a data source or data sink where we can just put all these events in very quickly, then we can just scale out very easily. And this is, of course, where Cosmos DB comes in. Because Cosmos DB, what we'll see, we are going to have events that are just documents. So we are going to use the document store in Cosmos DB. And Cosmos DB is very optimized for these high throughput, high insert workloads. So, and what is really nice, that this also can be done like multi-region with master. So we can actually have these events in from multiple places, and all of them will just insert the events. And in the end, we can just show, okay, this is projection of our order or of our object by just combining all these different events. Great. And this is something that you cannot do with normal database. So let's have a look at event sourcing on Azure. And Olena, can you tell a bit more about the other things that Cosmos DB can do?
Of course. You mentioned quite some points. And beside this, what I want to add that for event sourcing, Cosmos DB is a great fit as a central, append-only, and persistent data store. And of course, we have a change feed, and we're going to talk about this a bit later. But change feed is also our persistent event store, and we're going to have a whole history of changes which is happening in our system, and we can easily replay them anytime when we want to.
Yes. And so, of course, we are not just going to expose our Cosmos DB to the outside world. Instead, we are going to decouple this. So what we are going to do is we go implement event hubs in front of this. And then all our producers will send their events to event hubs. And this is like a high throughput streaming service where you can just have a stream of events and then have consumers listen to this and process those events and then send them out to the different destinations.
Great. And I'm pretty sure that Azure Functions is going to be a great fit for us. We can use Azure Functions to populate data in Cosmos DB. What we also can do is use Azure Functions with Cosmos DB trigger to receive those events and basically create our materialized view or transfer data to another containers, basically to duplicate it if we need it.
Awesome. So let's have a look on the demo of this. And what we are going to demo is an ordering system. So we are going to receive orders. Those orders are going to be sent to the warehouse. They might accept them. They might start picking them. So basically, we are going to simulate different systems. In this case, you are just using one application, but just because this is demo, in real life, there will be multiple applications, of course. And what we are going to do, we have a Kafka producer, so just a Kafka application, and we are going to connect this one to event hubs. And this is nice about event hubs, because event hubs actually has a Kafka compatible endpoint. So in our Kafka application, we only have to switch our endpoint, and it'll just work with our event hubs. At that point, we have the stream of events coming in, and we are then going to use Azure Functions to actually process this stream. We are going to transform the data, and we are then going to send it out to our Cosmos DB, where it will then be stored and can then be processed further. So let's have a look what this looks like. So first of all, I have my Kafka producer here. So this Kafka producer, as you will see over here, I have my producer. And if I go to the definition of this, you will see this is actually just the Confluent Kafka library. So in this case, I'm using .NET. Of course, it would be the same in Java and stuff like that. I just like .NET a lot myself. But if you have any Kafka-enabled producer, you can just switch the connection string, move it over to my Event Hubs connection string, and it just works. So what we are going to do in this application is we are going to create some tasks, and those tasks are going to process orders. Now, what we are going to do is basically you are going to go over these different events that our different systems would push out here. So we have like requested, update, accepted, updated, cancelled, picked, delivering, all those different events that you would expect for an order to go through in the different stages of those different services. So let's start this, and so it can actually run for us. And while this is running, we are going to go out and just, let me just check. Okay, so we are going to go over here. Just so we are going to run the 100 different tasks, 100 different orders. So while this is creating 100 different orders that are now being pushed into event hubs, let's have a look at the function that's actually going to process this. So the events are now just being sent to event hubs, and I already have a function running in my Azure environment. And that function basically has this event hub trigger. So this event hub processor is just going to process all those events. As you can see, the event hub trigger, it's got a connection to my event hub, and it's going to just receive an array of events. Now, these events are then going to process, and we are going to store them in Cosmos DB. So here I have some different options. So I could just have used the output binding for Cosmos DB and use that to actually send them off to Cosmos DB. The thing is, I want to change some of the things on my connection that I cannot do directly on the binding. In this case, I want to ignore some null values, but this might be anything that you want to change. And there's some different options there as well. In this case, I'm just using this SDK right from here. I could also have something like dependency injection or stuff like that. But just to show you quickly how you can use these different options, I just use the client over here. I'm going to connect to my database and my container, and I'm using that to actually process these data and push them into Cosmos DB. I'm going to look to my different events, and at this point it's very easy because I just have this event body that I can then use to actually get the data out of my event. This is very easy. This is completely abstracted by that trigger for my event hubs, and my functions just make it very easy to do this. I deserialize my object, I create an open order out of this, and I'm then just going to push this into my Cosmos DB. So at this point, my Kafka producer is running, I'm pushing the events to event hubs, my function is running in my Azure environment, and is pushing this data into my Cosmos DB. So let's have a look at my Cosmos DB and see what this looks like. So here in my Cosmos DB, I have my database over here. I have this collection of orders over here. And let's have a look in here because there should be quite some orders already. And indeed, there are many different orders here already. So if I look at this order, I see that I have an order here that has a requested event. And let's have a look at, okay, what events are actually already created for this specific order. So I can grab the order number here. I can say, okay, filter on this. I apply the filter, and I can see there's already 3 events for this. So I have my requested event, and as you can see here, there's information about, okay, the customer, the articles, that kind of things. I have an accepted event, and here I see, okay, I just have order status. I don't see information about my customer anymore and stuff like that, because we are just going to use these different events to build a complete view of my order. And the third event here is my picking event, which is just saying, okay, it's now being picked. At some point, it will go out for delivery and things like that. As you can see, it's now out for delivery. And at some point, it was delivered. So with that, we have now seen how we can produce these events, how Event Hubs is to just create a stream out of this. We can then read that stream using our functions and push it in Cosmos DB. So we have in Cosmos DB, but now we want to start making a view out of this. And Olena, can you show us how we can actually make a view for our different clients for this?
Of course. First of all, thanks a lot for a great demo. And now, as we already saw how we can write data in our Cosmos DB, let's talk about how we can then read it. So if we have a lot of consumers, that would be natural if you want to represent data for each of the consumer differently. So what I would normally do using relational database, for example, I would just create a query and I would just call it every time when I need to read this information. But for Cosmos DB, we might want to do something different because our query might be quite expensive because of the logic inside a query itself. And especially if we have cross-partition query when we need to access different containers. So, but we still want to have our queries in efficient manner. So what we can do in this case, we can generate pre-populated views. Basically, it means that we're going to store result of our queries in a separate containers or the same container if it's the same partition key. And we can do this regularly every time when there is a change happening in our database. And Azure Cosmos DB change feed going to help us in this case. Let's have a quick look, closer look on change feed itself. So when we are writing changes in a container, those events, those documents going to be stored in change feed itself. And when we want to create materialized views, there is a couple of ways how to do this. So first of all, we can use a pool model, and as name suggests you're going to extract all those events from a container or a specific partition key, and you're going to decide how to process them. This is quite a hard way to do because you have to manage everything on your own. But there is a great use case. If you need to read your data only one time, for example, if you want to transfer this data or create another materialized view for a new consumer or for existing one, if something happened in your system, this is a great way to go. Another option is change feed processor. You can use change feed processor library. You can subscribe to a container, and every time when there is a change happening, those events going to be pushed, and you just have to implement the logic, how you're going to process them and what kind of materialized view you want to create. But of course, in this case, you still have to deploy this. And the easiest way, in my opinion, is to create Azure function with Cosmos DB trigger. You also have to specify which container you are listening to and write your code. But later on, you can just publish it to Azure, and Azure going to take care of the rest. So as we now have an idea how we can do this, let's have a quick look in actual implementation. So we already
do that though, Olena. You're saying like we are going to create views for different consumers. That sounds a lot like we are duplicating data. Now, I always learned with databases, you should never duplicate your data. You want to normalize everything. Can you elaborate a bit on this?
Of course. So when we have read operations, they, of course, cheaper than write operations. But if we have complex queries, especially when those queries should access multiple containers, this is going to be the most expensive operation, especially when you have to execute it every time when your consumer want to receive some data, want to read something. So this is duplicating your data is a great way to save some costs. So you're making your write operations a bit more expensive. You write your data, then you create materialized view with the Azure function or change feed processor or whatever you want. Then you store this information. It's kind of pre-calculated queries already. You store this in a separate containers. And then every time when you have to read it, you just search for your document and just show this data. You don't execute this query over and over again. That's why we need to duplicate it.
Awesome. Sounds good.
Okay, great. So we already saw the first part of the demo when we showed how to write data in Cosmos DB. What we're going to do now, if we're going to have a look in Azure function with the Cosmos DB trigger, how we're going to receive those events and transform this data into materialized view, and we're going to store them back in Cosmos DB. So later on, our consumers just can read this data easily without executing those queries again and again. Let's go to our code. Yes. So this is how our Azure function looks like. When I created it, I just specified the name of my function, and I choose, again, I will repeat myself, Cosmos DB trigger. You have to specify some settings like which database are you listening, like which container you subscribe to, and you need to specify Cosmos DB connection. Just a quick look. In a connection string, there are going to be account endpoint and account key, and this information you can find easily in Azure portal for your Cosmos database. You also have to provide a list collection name. And this, we need to do this because it's going to maintain state across multiple Azure function instances. And you also have a flag if you want to create this collection. If it's not exist, you can set it to true or false. So we are receiving read-only list of documents as our input. We're also receiving a logger if you want to log some information. I'm going to get back to those two lines in a second. Let's first have a look what we are doing here. So I'm writing how many documents I received, just simple log as an example. And then I'm iterating through my documents. As you can see here, I'm deserializing it back to order object. And then I'm creating different views. I'm doing this in one Azure function, but in real world, you might want to have like separate Azure functions for each of the materialized view. This is just an example. So what we're going to do here, the use case for this could be if I want my customer to be able to see all his orders and all the items he ordered. So I'm going to create aggregation of data from customer perspective. So I'm checking if I already have this document. If I don't have it, I'm creating a new overview. If it's already exists, I'm just checking what I have to do. Should I add a new order because it was newly created to a customer information, or I just have to change the status or whatever other logic you want to have here. For hub aggregation, to be able to see some dashboards in my warehouses, like how many orders I received today, I'm doing this aggregation by incrementing count every time when a new order is created in the system. So if I already have, for my current warehouse, a document with this aggregated data, I'm just going to make an increment. If I don't have it, I'm going to create a new overview. What is interesting here, as you can see for partition key, I'm using synthetic partition key. I'm combining my hub ID because I know that it's a unique value, and datetime. I'm doing this because I'm interested on my dashboard on like monitors in warehouse, for example. I want to see what is happening today and not yesterday. Of course, I will have all this information stored in database anyway if I need to access it. But I want to see on those monitors count amount of orders in my warehouse for today. So as I promised, we are going back to those objects. We have customer overview repository and hub overview repository. These are basically the same functionality. The only difference that I'm using different containers in this case. Of course, in the real world, you will have much more than this. Our base repository has three methods: create, update, and get document. When we are reading document, as I said before, I know that my value is going to be unique, and I'm saving my partition key as a document ID as well, because I'm sure that they're unique. And I'm providing ID of my document and partition key because this is going to be a point read. So when I'm going to execute this method, I'm going to know for sure what document exactly I want to access. And this operation gonna consume really like small amount of resources. For 1 kilobyte of data, you're gonna pay like, it's gonna cost 1 RU. And here, if a document exists in database, we're gonna receive it back. If it doesn't exist, we're gonna, a Cosmos exception gonna be thrown. In my case, I want to create this document if it's not exist, so I'm just returning null. Of course, you might have more logic here. For creating document, two things I want to mention before we go further. First of all, try to always provide a partition key. This is a good practice. I'm using .NET SDK, and this partition key value going to be extracted anyway, because when I'm creating my container, I'm specifying what is partition key. But this is just a small optimization, so your SDK don't have to search for it, but instead you provide it explicitly. Another thing is, if you want to write data and you are not interested in receiving response, like this newly created or updated document, you can provide on each request item request options. And here you see there is a flag, enable content response on write. I set it to false, so I won't get this data back. Of course, when you created this Azure function, it's super easy to publish it just in a couple of clicks. In Azure, you select where you want to publish it and click the button run, and you're good to go. Let's go back to Portal. So when we were creating orders in the previous part of the demo, my Azure function was already published and was already running. So it's not a cheating, we just tried to save some time. As you see, it's the same data as we saw before. And you also can see that there is some containers were created. So what happened here for my hub monitoring? Yep, we see that there is some data exists. And as I said before, I'm combining my hub ID with data, and my ID of the document going to be the same as partition key. So what is happening here? I know which hub, which warehouse I'm using now, and I have a count of my orders. Those are new orders. Those are how many orders I received during this day. And we have different numbers. So what is happening for a customer? Oh, let's refresh it. We have quite some data. So let's have a look. As I said before, for my customer, what I want to do is I want to show aggregated data from customer perspective. And I'm doing the same. I'm using the customer ID, which is my partition key, as a document ID. And you can see that there is a count. My customer has 2 objects, 2 orders, and one of them was accepted already, and there is the order number and all the items which were ordered. And there is a second order which is also delivered. So yeah, that's all for demo part. And before we will finish our presentation, I want to summarize. We want to summarize all what we said before and a couple of key takeaways. So first of all, again, Cosmos DB is a great fit for event sourcing as a central append-only persistent data store. And about event sourcing, and let's say a couple of words.
Yes, so event sourcing is really for those heavy write loads, and that's why I love to use this with Cosmos DB, with event hubs, with functions, because it's really about like hundreds of thousands or millions of producers all pushing data at the same time. And this just works so nicely together, all of this.
Great. And we already saw how easy it is to prepare materialized views for various consumers, and also because of change feed as a like central and persistent event store, all our materialized views created from the same events. It means that we have a consistency, and anytime when we want to have more of those views for new consumers, or if something happened in our system, we can easily travel back in time and rerun all those events in a way we want to see it.
Yes, and finally, make sure you use that Azure ecosystem. There's a lot of different services out there that you can actually use with this and make smarter solutions, make better solutions. For example, think about Synapse. You have Synapse link with Cosmos DB, and you can actually get all the data from Cosmos DB and start doing all your things like getting insights into your data, start doing machine learning on this, and all this kind of stuff, which makes your solutions much more powerful.
Just a small comment on it. When I was looking into Cosmos DB from the very beginning, for me it was really important to be able to have a real-time heavy aggregation of my data. And if anyone has the same use case, I highly recommend to have a look in the Azure Cosmos DB connector for Apache Spark. And that's the end of our presentation.
Yes, so thank you everyone for being here today. I hope you enjoyed the show. We definitely did. So, like I said, if you have any comments, questions, whatever, my social media details are here. And thank you, Elena, for being an amazing co-speaker today.
Thank you, Eldar. It was my pleasure to share this virtual stage with you today. And of course, feel free, if anyone has any questions, to contact me on LinkedIn or Twitter. And have a great rest of the conference.
Thank you all.
Thank you.